Whoops. Hey guys, so we are going to start chapter 9. Here's 9.1. I recommend that you have your notebook ready, pause the video when needed to take notes for tests and quizzes. So 9.1, now we're getting into graphing parabolas, which are also called quadratics. A quadratic function is a nonlinear function that can be written in the standard form y equals ax squared plus bx plus c, where a cannot equal 0. That is the coefficient in the leading term. Every quadratic function has a U-shaped graph called a parabola. In this lesson, you will graph quadratic functions where b equals 0. So here's our parent function. A parent function is when nothing is affecting the x. So there's no coefficient in front of the x squared, and then there's no constant after. So in this format, it's always going to have that U shape. This, the lowest point is always going to be at 0, 0. And it's going to be always symmetrical on both sides. So make sure that you pause and write this information. Vertex here is always at 0, 0 for the parent function. The axis of symmetry, it is in the middle of our parabola. And what's happening is that it's symmetrical on both sides. So if you look at this specific point here, it's exactly one space away on this side and exactly one space away on the other. It's symmetrical on both sides. So for example 1 wants us to graph y equals 3x squared. So I have it on my whiteboard. I already have it ready. Let me straighten this out. So we're going to graph y equals 3x squared. So I already made my table, picking the standard numbers like usual, -2, -1, 0, 1, 2. So when it comes to graphing parabolas, this is the only way to do it. You got to make a table so you have your exact points. So when you turn in a quiz, the best way to get those points is by making the table. You should already have a general idea, but making the table gives you some really exact points. So this is going to be a little bit different than our parent function. Since we have this coefficient 3, it's going to affect how our U-shaped parabola is. So whenever you have a whole number, it's actually going to make the parabola get closer to the y-axis, where if you have a value that's less than 1, it's actually going to open up your parabola. So we're going to start with our x values, and we're going to plug it into our equation. So y equals 3. I'm going to plug in the value of -2, and we're going to square it. Well, -2 times -2 gives us 4. So this ends up being 3 times 4. So we get 12 for our first value. Now we're going to plug in the value of -1, and we're going to square it. -1 times -1 gives us 1. Well, 1 times 3 is 3. Then for 0, y equals 3 times 0 squared. Well, 0 squared is just 0. 0 times 3 is 0. Be careful, don't put 3. Then for 1, it should be exactly the same as here, because whether we square 1 or -1, we're still going to get the same value. So 1 times 3 is 3. There's that mirror image that's happening. And then 2, and negative 2, it's going to be the same value. So then I have the graph ready. Straighten it out a little bit. I did my graph in increments of 2s to make sure that it fit properly. So we're going to plot our first point. So let's plot our first point. So negative 2 and positive 12, 2, 4, 6, 8, 10, 12. Then negative 1, so I'm going to go halfway, and then positive 3. This is 2, so halfway would be here. Then 0, 0, it's our vertex, our lowest point. And then 1, 3, it's always going to be a mirror image. And then 2 and 12. When we connect the points, we get this U-shaped parabola. Not that perfect, but got the job done. So that's example 1. Now we have example 2. Ready? So for example 2, just going to show my whiteboard. I already copied all the examples. For example 2, it wants us to graph this. Y equals negative 1/4 x squared. So remember the parent function, if that didn't have anything in front, if we had no coefficient in front, it would just be a regular parabola with that vertex at 0, 0. But we have a coefficient that is smaller than 1. Therefore, our parabola is actually going to get wider. Anything less than 1 will get wider. Anything bigger than 1 actually makes the parabola smaller. And since it's negative, that's also telling me that my parabola is going to be upside down. So since you know anything squared gives us that U shape, you should already start having a picture of what your graph should look like with that coefficient in front. So I forgot to make a table. Make a table. X and Y. And we're going to pick points a little bit different since we're dealing with a 4. It's actually going to be easier if we pick negative 4, negative 2, 0, 2, and 4. Depending on what values you have, you can pick numbers that simplify easier than others. So now we're going to plug in our values to get our ordered pairs. So we have y equals negative 1/4, and we're going to multiply that by negative 4, and don't forget we have to square it. Well, negative 4 times negative 4 gives us 16, so we have negative 1/4 times 16. We'll erase it after. Don't forget the rule when you multiply fractions, you multiply straight across, so we would be left with negative 16 over 4. I'm going to write it here and then I'll erase it. Negative 16 over 4, which that then simplifies to negative 4. That's our first ordered pair. Negative 4, negative 4. So copy that into your notes. Next value is negative 2, so we're going to plug it in there. So I'm going to write it and then I'm going to erase it. Y equals negative 1/4, negative 2 squared. Well, negative 2 times negative 2 gives us a positive 4. So we have negative 1/4 times 4, multiply straight across, so we get negative 4 over 4, which is just negative 1. I'm going to erase that. Then we're going to plug in 0. Y equals negative 4. Negative 1/4 times 0 squared. 0 squared is just 0. 0 times negative 1/4 is 0. Then we're on to 2. Well, now it's just a mirror image, so we're going to get the same values. So negative 1, negative 4. So you basically just have to do the first 3, and then the positive values are going to have the same as the negative. So now we have all of our ordered pairs. I'm going to erase this so we can graph. So -4, -4. That's our first point there. Then -2, -1, 0, 0. And then we have this mirror image that's happening. +2, -1, right there. And then 4, 4. So as expected, our parabola is much wider. And it goes upside down because of that negative. That was 2. Now we're going on to 3. So here we have another x squared where we don't have a coefficient. So it is going to be just like our parent function, our u shape, but now we have a constant. So whenever we have a constant right after, this actually is going to be our y-intercept. Just like how we would graph in slope-intercept form, whatever that constant is, that's always going to be where it goes through the y-axis. The only difference is that with parabolas, this constant is going to be where the vertex lies if there's nothing else going on. So if we have something squared with a constant after, that is going to be where our vertex is. So that means 1, 2, 3, 4, 5. Our vertex should be right here, and then it's going to go up like this. Well, we're going to verify it now when we plug in the values. So for -2, y equals -2 squared plus 5. So -2 times -2 is 4. 4 plus 5 is 9. So -2, 9. Now we're going to do -1. Y equals -1 squared plus 5. -1 times -1 is 1. 1 plus 5 is 6. Then 0, y equals 0 squared plus 5. 0 plus 5 is 5. That's exactly where our vertex is. And then we have this mirror image happening. So -2 and then +9, which is going to be all the way up here somewhere. -1 and 1, 2, 3, 4, 5, 6 here. 0, 1, 2, 3, 4, 5, just as we expected. And then we have this mirror image 1 and 6 right here, and then 2 and 9. So whenever we have a constant after, it's going to affect where this vertex of the parabola falls. So that was 3. And then we have our last one, our last graph that we're going to work with. So we know that our y-intercept is this -4. And then this coefficient in front of the x is telling me that our parabola is going to be much wider. So let's start the calculations. Y equals 1/2, our x is -4, squared minus 4. So just by looking at this, this is telling me my parabola is going to be much wider than my parent function, and its vertex is going to sit 1, 2, 3, 4 right here. So it should cross right here and then open up kind of wide this way. So let's simplify this. -4 times -4 is 16/2 minus 4. Well, 16/2 is 8. 8 minus 4 is 4. Now for -2. Y equals 1/2 -2 squared minus 4. -2 times -2 is 4. 4/2 minus 4. Well, 4/2 is 2. 2 minus 4 is, shouldn't be right. 2. Yeah, no, that's fine. Correct. Now I'm going to erase this. Let's plug in 0. Well, 0, we know it's just going to be -4, but I'll plug it in. 1/2 times 0 squared minus 4. 0 squared is 0. 0 times 1/2 is 0. 0 minus 4 is -4. And then we have this mirror image of -2 and 4. Now I'm going to erase this. Now we're going to plot our points for our graph. So -4, 1, 2, 3, 4. Positive 4, 1, 2, 3, 4. Erase. Right here. So -4 and 1, 2, 3, 4. -2 and -2 right there. 0, 1, 2, 3, 4, which is what we expected. +2, -2, and then 4 and 4. So it's a large, wide parabola, and our vertex hits at -4, which is our y-intercept, which was expected. Okay, guys, that is the end of 9.1. Make sure to watch 9.2. Bye.